This is The Future Of, where experts share their vision of the future and how their work is helping shape it for the better.
Hello, I'm Tom Robinson. Our environment is a fascinating web of ever-evolving, intricate and diverse systems. It's comprised not just of plants and animals, but rocks, soils, waters, gases and microorganisms that we rely on for our livelihood and survival. Understanding what makes up our environment and how we can protect and conserve important ecosystems is key to ensuring an inhabitable Earth for future generations of species. To discuss this topic with me today are Professors Simon Wilde and Stephen van Leeuwen. Professor Wilde is a geoscientist in the Curtin School of Earth and Planetary Sciences. Professor van Leeuwen is the BHP Curtin Indigenous Chair of Biodiversity and Environmental Science. Thanks for coming in today, Simon and Stephen.
Thank you.
Thank you.
Stephen, what makes Australia's environment so biodiverse and in need of greater protection?
Well, Australia is one of the mega biodiverse countries in the world. There are 17, and Australia is one. And our big claim to fame is our number of species. There's about 600,000 species that occur in Australia. For example, in the vascular plants, we've got a flora of about 26,000, and 87% of them occur nowhere else in the world. It's just restricted to the Australian continent. We're mega biodiverse, as I said. In WA, there are 8 biodiversity hotspots. We have more than anywhere else in Australia. The rest of the 7 biodiversity hotspots occur over on the east coast. And Western Australia is also the only place in Australia where we've got an international biodiversity hotspot. Now, to be a biodiversity hotspot, you've obviously got to have lots of biodiversity, and you've also got to have lots of threats. So, for example, in Western Australia, the southwest corner of our state, we've got a huge number of plants, animals that are endemic to the southwest, but we've also got a huge number of threats from land clearing, inappropriate fire regimes, a drying climate. Perth's rainfall, for example, has decreased by 30% in the last 20 or so years. So that's putting huge pressures on biodiversity. We also have things like clearing and fragmentation in the wheat belt. Diseases like Phytophthora, Jarodiabac is a common name, but Phytophthora cinnamoni, which is a root fungus. So we've got major threats in addition to having a biodiversity hotspot. And a great example of how biodiverse we are in terms of the plants is the Stirling Range National Park down on the south coast near Albany, where there are more plants in that national park in the whole of the United Kingdom. That's a really good example of biodiversity in Western Australia and Australia.
Does the range of species come from the isolation of Australia?
The isolation and the progress of Australia over time, evolutionary times, from a cold climate when it was part of the greater supercontinent called Gondwana, and as it's moved further north to the equator, slowly with continental drift and plate tectonic forces, we've gone through a series of mini climate and those climate cycles influencing the evolution of soils and landscapes and landforms, and that has enabled us to have a really diverse flora and fauna. We've probably got the poorest soils in the world. A colleague of mine, Professor Stephen Hopper, who's at the University of Western Australia, has named them Ockbill soils. Our soils are extremely poor, but our plants, and as a result of that, the animals that rely on our plants have adapted to them, and that's why we are part of the reason why we're so biodiverse.
Simon, to some people, rocks may seem attractive yet very prosaic parts of the landscape. Why is it so important that we take care of them?
I guess picking up on Stephen's point there, the key to the rocks is that they break down over time to give you the soils, whether they're poor or not. And a lot of the diversity that we do see actually is related to different rock types. We have a wide range of rock types in nearly every part of Western Australia, I guess, except perhaps the Great Sandy Desert. So that is the key. I mean, the Earth is 4.5 billion years old, and we don't notice these changes in our lifetime. But the rocks are breaking down. You can go to quarries on the Darling Scarp and you can see that rocks are falling off periodically. the whole thing is to high relief, just gets removed and comes down to a base level. That's the idea. So the rocks weather down and they produce a soil along the way, which is variously transported by rivers and streams. And so it's really the basis for that, I guess. That's the most important thing, why people should take a note of the geology, because it does have a strong controlling factor. Like Steve mentioned, the Jarrah. The Jarrah is very pristine. It goes on to the southwest. But the rock types, again, are quite uniform where the best Jarrah forests are. And you see Wandoo, the white gum going across. They actually follow the dolerite dikes, which actually cut through the granites, which the Jarrah seems to prefer. So there's a very strong connection between, certainly between the plants and the bedrock.
I just want to give you the opportunity to speak about some of your research going away from maybe Australia and into, well, North China. You're a recognised expert on the geology of this region. What's interesting about this area from a geoscientific perspective, and what are some of the practical applications of your research?
I went into China way back in 1988 for the first time, and I found it was really an open slather for the sort of work we were doing here at Curtin. We were set up to do geochronology. There was really, particularly in North China, no one really knew the age of the rocks. They could have been 3 billion years old, 2 billion years old, or perhaps even formed just perhaps 100 million years ago. So it was an open field. China has many advantages. They support education, and they support research. So the difficulty we have here getting money from the various government agencies is not an issue in China. So it was very good for funding the research. And as I say, being an open field, the rocks in China, particularly the North China, go from 3.7 billion years old to fairly recent deposits. And one of the things that China has done, which is relevant to what we're talking about today, is they have geoparks. And they put a lot of effort into setting up these geoparks. They produce beautiful brochures on this. It includes everything. It's not just the rocks, it's partly that, but it's also the topography, the vegetation, the animals that can go in there. And I've nominated one in China, which got through, and I've also been on the UNESCO panel, which set up another one in North China. So there's a lot of opportunity. I think that's one of the things in China. And of course, this idea of geoparks is something that we're probably taking a little bit on board here, because we were very fortunate in having the Jack Hills in Western Australia, 800 kilometres north of Perth, recently put onto the National Heritage. We've been trying for 10 years to do this, but it's got on at last. And the reason we did that is because this contains the oldest crystals on Earth, 4.4 billion year old crystals, which you can find a few crystals of that age in other parts of the world, but there's 16 locations now, including in China. But the advantage of Western Australia is the abundance of those crystals that allows us to look at conditions on Earth way back almost from the beginning of time.
Stephen, mineral exploration and extraction is a primary income source for the Australian economy. But it's also responsible for the destruction of important ecological and cultural sites, with Juukan Gorge a recent example. What can be done to achieve a better balance between exploration and conservation?
I think the key is having the information to make informed decisions about land use planning in all its senses, and that includes conservation, planning and biodiversity management, and land management or natural resource management in general. The more information we have, the better decisions we can make. And for a proponent of a resource development, the more information they have, such as the geology, they can make informed decisions about the economics of it. Just as if they have more information about the biodiversity environment, they can make informed decisions about the risk that poses to their operations in terms of approvals and in terms of the activities they'll have to undertake to manage their impacts. Now, getting that information is the challenge. As I said, we've got a very biodiverse continent, 600,000 species, but unfortunately, most of those species we don't know. We have them in collections, but they don't have names on them, and because they don't have names, we're not able to determine their distribution or their conservation status. So while Australia is a first world nation in its economy and our lifestyles and living, our knowledge of our biodiversity is third world. So we're continually finding and describing new things. Currently, the West Australian Herbarium's journal called Noitsia It's their anniversary year, 50. I think it's the 50th year. I should know that. But they're describing a new plant every week this year. And one of the species they've described as a small plant known from one location at Welshpool in a trucking yard, and it was only collected 3 years ago. So that's how it's sitting basically in Perth CBD, never collected before, and it's new to science. So we've got a long way to go. So, but once we get that information, then it's how we use that to inform. It's not only mining developments, but for example, Swan Coastal Plain, we've got major issues here with development because of the people population and a huge number of threatened species. The most charismatic one, arguably, Carnaby's cockatoo, is slowly heading down the drain to extinction because a lot of its habitat gets cleared. It's feeding habitat because we need to put up more houses and build more, rural developments.
Simon, how are advances in technology leading to more efficient mineral exploration and extraction?
Picking up the point there, I guess, that Stephen was making, we do need a lot more information. Yes, most geologists would like to go out in the field, and you do need to do ground truthing. But there's greater awareness now that we can use other methods. So there's remote sensing from low-flying aeroplanes, satellite imaging. People can actually identify types of minerals or actually picking up elements which relate to minerals from a great distance. You don't need to go into the field. Very good for remote locations. And geophysics in general, where you don't actually disturb the ground. You simply walk along with a magnetometer or something like that, and you get a lot of information of what lies beneath the surface. And there are major initiatives to look at this type of exploration across Australia. It was done for the regolith in Western Australia beneath the laterite by the CSIRO many years ago with a very concerted effort really to try and work out what areas were prospective. So there's a growing use of remote technology in looking for mineral deposits. There's also more subtle ways of taking very small soil samples, even water samples, and looking for traces either of the mineral or element of interest or of pathfinder elements which might lead to location of additional ore bodies.
Stephen, what are your thoughts on the Australian government's proposed changes to the Environment Protection and Biodiversity Conservation Act? Do you think these changes will afford greater protection for significant species, habitats and heritage sites?
Yes, a really interesting question, especially given the current review of the Environmental Protection and Biodiversity Act by Graham Samuels. There are numerous challenges in there, and heritage is one. But from the Indigenous Advisory Committee and the Indigenous side of things, and I'm heavily involved in those aspects of the review, it's about, again, having better information to make better informed decisions. So the review is proposing to come up with standards that proponents and the general community need to adhere to for approvals, for managing threatened species, for looking after the National Reserve System. Those changes, if they're adopted, will be a good step forward. And yes, they will probably improve the approval process and the time frame, and redress issues associated with green tape. But also on the other end, red tape. Often, again, it comes back to proponents having enough information to make informed decisions about their development and the risks that they might encounter.
Indigenous Australians have complex land management systems, and these were in practice before colonisation. Can you tell me about some of these practices and how we can use them to help conserve and enhance Australia's environment?
Yeah, there were numerous practices. Indigenous Australians were the first engineers, environmental engineers particularly. Last year, the Bunabin World Heritage Area in Victoria was listed because of its cultural values, and basically that location, there's a series of eel traps that were built 50,000 years ago by the Indigenous people, and that's a major engineering feat. And when you think about that, that's a long time before the pyramids were built. places like Jakarta Gorge in the Pilbara, people were there 65,000 years ago. Yes, the engineering feats may not have been so great, but still being able to work with fire and manage country using fire was part of the lifestyle then. And fire is very topical. Indigenous or cultural burning has been proposed as one of the new approaches to managing fire across the south of Australia, or southern Australia. It's already used in northern Australia for tropical savanna burning. We are now looking to bring that program, those processes, back to southern Australia.
What happens, or what will happen, if we bring those processes back? What are some of the benefits that come from using these practices?
The immediate benefits, and this is an example from northern Australia, is the abatement of carbon. So big wildfires like happened last summer in southern Australia, they put a huge volume of carbon and other greenhouse gases into the atmosphere. Managed fires, whether you call them prescribed fires or cultural burning and that, are not as intense, and thus the amount of climate impacting chemicals, emissions that go into the air, is significantly less. So that's one of the immediate benefits. There's also benefits to biodiversity, benefits to the distribution of threatened species. We know that in some locations, because there's been a lack of fire in the last 200 years because traditional burning has stopped, the community has completely changed from a grassland to a eucalypt woodland. Or in a couple of instances, particularly in Tasmania, we know it's changed into a tropical rainforest. Now, yes, there are really challenging community discussions to have there. If we bring back in traditional burning, do we really want to change it back to a grassland? Because maybe the rainforest is bringing us lots of tourists out of the community. But if we bring it back to a grassland, there's going to be a whole suite of animals that will come back that are not there now because they don't live in rainforests.
Simon, what are some of the ways people can develop a greater appreciation of planet Earth?
I think, again, I'll pick up on Stephen's point there, which is about climate change. I mean, the climate is very much controlled by the disposition of the continents. The continents are continuously moving. They're not moving that fast. It's about I think the growth rate or the movement rate of a continent is about the growth rate of your fingernails. So you won't see it moving, but you can measure it. And I think the important thing to remember is with plate tectonics, or the old version which was called continental drift, the continents are not where they originally were. Stephen mentioned about Australia is going northwards fairly fast. India went northwards about 60, 50 million years ago, collided with Asia, and that's why we have monsoons. The whole of that monsoonal weather pattern is controlled by the fact you've got the Himalaya. You've got such high mountain chains. They've not always been there, and they won't always be there because of the erosion. So I think it's a greater appreciation of the importance of geology. We need to take a global view. Again, we can look at geology in Western Australia, but to get a better understanding, we look at similar age rocks, similar type of rocks all around the world. We know, for instance, Gondwana, which was the last of the supercontinents, that broke up. So we can see similar rocks in South America, Antarctica. You don't see them too well there, but they're there. And in South Africa and Africa, and you can look at all these things, and you can see that the continuity, really, of geological processes, including like the laterite, which is very prominent here in the southwest, where that developed probably at least 40 million years ago, and that's sort of hardened over time. But that is also present in, that's why the iron ore deposits are in Brazil. It's because it's a similar sort of, not current environment, but at the time that those deposits formed, they were together and they had a very similar climate. So I think if people appreciate how important the continents are, the disposition of the continents are on planet Earth, they'll get a greater understanding, I think, of these processes such as climate change.
Stephen, did you have any thoughts on this?
Climate change is a major challenge for the community, and it's where do things go? And I'm going back to my earlier comment about the threats to the biodiversity hotspot of southwest Australia. Fragmentation in the wheat belt has meant that it's not easy in evolutionary times for things to move across the landscape anymore. So where do things like the Jarrah forest end up, if climate change continues and Perth continues to lose rainfall, where does, we had, it must be 5 years ago, we had a couple of really hot days. We had Carnaby's cockatoos falling out of the sky. So, appreciating those extreme events, climate, and how climate change is influencing them, and the future for biodiversity, and we are part of biodiversity. We've got to remember that. We are part of the system Earth, planet Earth. We need to be cognizant of that and think about how we can manage better the emissions we make, the decisions we make, the information we have to make those decisions.
Well, I think it's important that we don't forget our role in this system as well. I think that's all we have time for today. Thank you very much, Stephen and Simon, for sharing your knowledge on this topic.
A pleasure.
Thank you.
You've been listening to The Future Of, a podcast powered by Curtin University. If you have any questions about today's episode, you can get in touch by following the links in the show notes. Wherever you're joining us today, don't forget to like, comment and subscribe. Bye for now.